Today, 1/3 of ice platforms in Antarctica are at risk of collapse. And the largest slab of ice ever, called A76, which measures almost 4 times the size of New York City, has just broken off from the frozen edge of Antarctica. So why are glaciers melting so fast? A glacier is considered in equilibrium when the amount of snow that falls and accumulates on its surface is equal to the amount of ice lost through melting, evaporation, calving, and other processes. Unfortunately, global warming is not helping to keep this equilibrium. Quite the contrary. The last decade was the warmest on record, and the 6 warmest years ever recorded have taken place since 2015. And nobody is forecasting improvements. Imagine that if all glaciers and ice sheets melted, global sea levels would rise by more than 229 feet. Recent studies already predict that we will lose at least 1/3 of all our glaciers by 2100, and that will include most, if not all, of European glaciers. This will increase sea levels by approximately 3 feet, which could basically imply the demise of numerous coastal cities around the world. That's why most scientists consider that glaciers are approaching a tipping point, meaning the point when a small, reversible change becomes irreversible, forever. In the case of glaciers, this would imply unstoppable melting and dramatic rise of global sea levels. Since everything is connected on our planet, that doesn't even take into account the feedback loops, which could accelerate things even more. Feedback loops reinforce the impact of climate factors and tipping points, starting a chain reaction that repeats again and again. So for example, glaciers melt because of global warming, and by melting, their reflections of sun rays and cooling effect is reduced. Glaciers then start having dark patches that actually absorb the sun rays and accelerate global warming, which in turn makes glaciers melt even more.